Hello, geometry students. Welcome to Chapter 4. We're really cruising right along. Chapter 4, beginning of every chapter is really some basic terminology and ideas. I think a lot of this is going to be super review for you, but let's run through really quickly. First of all, Chapter 4 is all about triangles, and this section is called Classifying Triangles. I need to point out, I'm going to ask you two questions. I'm either going to ask you to classify triangles by the angles or classify triangles by the sides. So there's two different sets of answers that we choose from. So this first little box here is when we're looking at the angles. We don't really care about what the side lengths are or how they compare. So hopefully everybody knows what an acute triangle is. An acute triangle is all of our angles are less than 90 degrees. Oh, I thought I had something there. Oh, there it is. 3 acute angles. We don't know what they are. We just know they're all less than 90 degrees. Equiangular. Notice everybody knows equilateral triangles, right? Well, equilateral refers to the sides. Equiangular, hopefully you can recognize that root word in there. It's got angle in there. Equa means equal, obviously. Angular means angle. So all 3 angles are congruent, and they all happen to be acute. So an acute triangle is, an equiangular triangle is also acute. Obtuse triangles, one obtuse angle, the other 2 have to be acute. So one is larger than 90, the other 2 are just there. And last but not least, a right triangle. It has one right angle. The other 2 angles you may notice from that diagram are also acutes. So you can't have more than one acute or one obtuse angle in a triangle. We'll talk about that in a moment. So this is classification of triangles by the sides. So we don't have anything markings on how many sides there are or how many angles and how they relate. We only see the sides. So equilateral, I mentioned just a minute ago. Notice all 3 sides are marked as congruent. We don't know about the angles. We sneakily know about the angles, but maybe not yet. All 3 sides are congruent. Isosceles, everybody knows isosceles. Be careful. This one's a tricky one. It's not just 2 congruent sides, it's at least 2 congruent sides. So if the 3 sides are congruent, it technically is equilateral and isosceles. Scalene triangle, I think everybody knows. No sides are the same. It's just a triangle. So again, when I ask you to classify by angles, you're choosing from equiangular, isosceles, right, or acute. If I ask you to classify by sides, you're choosing from equilateral, scalene, or isosceles. All right, so not sure if you know the parts of a triangle. We've got a lot of parts of a triangle. A vertex or vertices are the points where the sides intersect. Remember, a vertex is a point. So I'm not sure if I have this up here. Nope, I don't. Points where sides intersect. It's kind of a crowded little area in here. Sorry about that. Make space or something. Hypotenuse is, well, actually I could do this. So I could say I have vertex A, vertex B at the right angle, and vertex C. Hypotenuse, we all know that's in a right triangle. It is the side opposite the right angle. So I'll put right triangle. I'm an abbreviator. Longest side. And across from right angle. I abbreviate right as RT and then the angle symbol. So in this particular example, side AC would be our hypotenuse. You cannot have a hypotenuse in anything but a right triangle. Legs, however, we can have in a couple places. So legs in a right triangle make the right angle. right triangle, I'll say form the right angle. So side AB would be a leg and side BC would be a leg. We all know that, right? From a squared plus b squared equals c squared. We know the sum of the square of the legs equals the hypotenuse squared. We know legs in a right triangle. I'm not sure if you realize, in an isosceles triangle, isosceles, remember, is when you've got at least two congruent sides. In an isosceles triangle, the legs are the equal sides. I'll put congruent sides. So in this guy, this would be a leg and a leg. We don't refer to it very often, but the book does throw some problems out there that says, well, in an isosceles triangle, the legs are, and so you need to know that those are the two congruent sides. Vertex angle is in an isosceles triangle. Isosceles triangle, that's where the legs intersect. So in this particular triangle I've got over here, this would be the vertex angle. And base angles are also typically just thought of in a isosceles triangle. And those are the two angles formed by the leg and the base, formed by the legs. Angles formed by legs and the base. So in other words, in this diagram, these two angles down here would be base angles. Makes sense, right? The base, we think of usually the bottom. I could flip that isosceles triangle around. We could still find the base. It's where the legs and the base intersect. All right, so let's do a couple practice problems. I think that's all the content stuff, so let's just talk about a couple of things. The first things are some true or falses. Give an example. Is this true or false? All isosceles triangles are equilateral. All isosceles triangles are equilateral. So what's isosceles? At least, whoops, oh, struggling. At least two congruent sides. And equilateral is three congruent sides, right? So are all isosceles triangles equilateral? No, because it could just have two, so that's false. So what about statement B then? All equilateral triangles are isosceles. So do all three-sided triangles with three congruent sides have at least two congruent sides? Why, yes, they do, right? So that would have to be true. So something to think about. We'll do that with a couple other shapes as well. All right. So classify this triangle. I wish that I had said instead, just classify this triangle by its angles, and that I hadn't given you this. Because then you'd have to know, oh, which pile of words am I choosing from? So my angles, I've got two answers on this one, right? Notice 60, 60, 60. So that's going to be equiangular. So I'm going to have to go back to that little box where it said classify the triangle by its angles. And this is also acute. Wouldn't you agree that all three angles are less than 90 degrees? So it's equiangular and it's acute. Let's skip this one. I think we get that. So this one, it says to classify the triangles by its sides. Actually, let's scooch to the next one. Classify its triangles by its sides within figures. So we've got this figure, we've got all these lengths on here. It says point Y is the midpoint of Vx. The whole thing, notice I give you the length of Vx. WY is equal to 3.0 units. Classify triangle VWY. VWY. So this triangle right here by its sides. So equilateral, isosceles, or scalene. So equilateral, 3 congruent sides. What is the length of VY? Hopefully you agree it's got to be 4.2, right? Because Y is the midpoint. We know midpoints cut something into 2 equal parts, whether it's a segment or an angle, a bisector. So it looks to me like I have 3 different lengths, which would be a scalene triangle. Just a little messy, but everything's there. You just have to read between things. Let's do a good old algebra problem. Find the measures of the sides of isosceles triangle KLM with base KL. So this side right here is the base. But what do you know about an isosceles triangle? At least 2 congruent sides, right? Well, here's the thing. Since they're telling us that the base is KL, that means that these two, KM has to be a leg and ML has to be a leg. And in an isosceles triangle, what do you know about legs? Legs have to be congruent. So KM has to be congruent to ML. If I write a geometric statement, I hope I don't confuse you. But now I'm just going to substitute values in, right? Instead of KM, KM is 4D minus 3. Oh, sorry, 4D minus 13. ML is 12 minus D. I've got myself an equation to solve. Hopefully you're good at equation solving. I'm going to add D to both sides. After I do that, I'm going to add 13 to both sides. And I'm going to end up with 5D equals 15. So that's an easy divide to get D equals 3. But notice it says find the measures of the sides. We're not quite done. D equals 3. So what does this side right here have to be? KL. Plug in that 3. Side KL has to be equal to 3 plus 6 or 9. Plug in for KM. So I'm going to put a 3 in place of that D. So 4D minus 13, or 4 times 3 minus 13. Did I do the wrong divide? Oh my goodness. Let's try that again. Wouldn't you agree that, are you wondering about my math? That's got to be 25, so D has to be equal to 5. If you wondered what I was doing, you were right. You should have stopped me and told me to stop. Okay, so now I'm going to put a 5 in there. So 5 plus 6, do you like KL as 11 better? When I put a 5 into KM, sorry about that, I get 20 minus 13, so that's got to be equal to 7. And when I put a 5, not 3, a 5 into ML, hopefully we get the same amount, right? 12 minus 5 is 7, because we said that KM and ML had to be equal to each other. So we've got those. All right, one last thing. It's everybody's favorite. I've got myself a coordinate plane. Use the distance formula to find the measures of the sides of triangle RST. Classify the triangles by its sides. So in other words, is it equilateral? Is it isosceles? Or is it scalene? Does it have 3 congruent sides, at least 2 congruent sides, or no congruent sides? In order to compare the measures of the sides, we have to know what the lengths are. So we're going to have to use the distance formula. Hopefully you remember that from chapter 1. x2 minus x1. It's not my day today. Squared, plus in the middle, y2 minus y1 squared. Take the square root of the whole thing at the end. So we're going to have to do 3 separate problems. I think it's easier to see when you are on the graph. So if I'm going to find the length of side RS, this guy over here, so the distance formula for RS, I'm going to set myself up an equation, and I'm only going to use R and S, so x and y 1 and 1, x and y 2 and 2. I can plug all that stuff in there. So I end up with a 4 minus negative 1, a 4 minus negative 3. That's got to be equal to, what is that? 5 squared is 25. 7 squared is 49. So side RS is equal to the square root of 74. Now I could go to my calculator. That's probably going to be an 8 point something. I'm just going to leave 74 because if something else comes up as a square root of 74, I'll know that they're the same length. If you prefer a decimal, go for a decimal. So then I'm going to find the length of, well, let's say, ST. Whoa, bad tracing. So distance for ST. So that means I'm going to take these 2 points, call them my X and Y, 1 and 1, 2 and 2, do myself a little math problem. You getting the hang of this? So after I do that, I guess I should probably do it, huh? All right, so 8 minus 4 and negative 1 minus 4. So ST is going to be something like 4 squared is 16. Negative 5 squared is 25. So that's going to be the square root of 41. So at this point, I have 2 sides. Neither of them are congruent. So now my last side, according to my diagram, is side RT. So distance formula for RT. Now when I go to my ordered pairs, I'm going to ignore S in the middle. I'm going to do R, whoops, X, Y, 1 and 1. And I'm going to do T. Because S has no part of this line that I'm working on. So I'm going to do my x2 minus x1, so 8 minus negative 1, and then negative 1 minus negative 3. So RT is going to be something like 9 squared is 81, 2 squared is 4, so the square root of 85. So that was a lot of work to figure that out. However, I've got everything I need to now answer the final statement, which says, classify the triangles by its sides. So if I've got a square root of 41, a square root of 74, and a square root of 85, do I have an equilateral, an isosceles, or a scalene triangle? Hopefully you see I've got no congruent sides. So this is a scalene triangle. Final answer and end of section 4.1. Lots of review, maybe a little bit of new. I've got a word problem over here, but I think probably it says it's an equilateral triangle, right? I feel like I need to talk about it now. Equilateral triangle, 3 congruent sides. AB is 6x minus 8. BC is 7 plus x. And AC is 13 minus x. Well, if it's equilateral, we know we've got 3 congruent sides. So pick any 2 and make them equal to each other. You can't have an equation with 3 parts in it, so pick whichever 2 seem easiest, solve it, and figure out what x is equal to. And then it says after you find x, find the measure of each side. So those ones are tricky because people want to incorporate everything. We only need one equation. It has to have 2 sides. So one of those 3 expressions you will not use. And that is the for real end of section 4.1. Thanks for hanging in there. And I'll see you for 4.2.